this video, we are going to deal with trigonometric polynomials in numerical methods. So how do we deal with the trigonometrical polynomials here in numerical methods? First of all, the moment you see that your polynomial has a tan, has a cos, tan, cosec, sec, those trigonometrical ratios, the first step is to put your calculator in radian mode. Okay, for trigonometrical equations, i.e. with sine of an angle x, cos x, tan x, cosec x, cot x, etc. The calculator should be set in radian mode. That is very important. The calculator should be set in radian mode. Let's have an example. The expression sine x minus a half x equal to 0 has a root. Let us have an example. The first example here show that the equation sine x minus a half x equal to 0 has a root between 1.0 and 2.0. Use linear interpolation to find the approximate root. So before we start, we get our calculator, put it in radian mode. Hope all of us know how to put our calculator in radian. So mine is put already in radian mode and I'm ready to feed in. So our solution is going to be here. First step, let f of x be equal to 0. If f of x is equal to 0, that implies that f of x is equal to this other 0, which is equal to sine x minus a half. Now they need us to show that the root lies between 1.0 and 2.0. So, as usual, we are going to use sign change. If you happen not to put your calculator in radian form, the moment you note trigonometrical ratios, you're not going to get the right thing. So it is always advisable, the moment you sense something here in numerical analysis that has trigonometrical ratios, please go ahead and convert your calculator first in radian. Put it in radians. So next we are going to get f of 1.0. This is going to be sine of 1 minus a half. This gives us sine 1 minus 0.5. That gives us, for the EPs, 0.3415 positive, right? Now we go to f of 2.0. This is sine of 2 minus a half times 2. So this gives us, pressing the calculator, sine of 2 minus 1. That gives us a negative 0.0907. Conclude and say, since f of 1.0 times f of 2.0, when you get this times this, you will get a value that is less than 0. It will be a negative value. So since f of 1.0 times f of 2.0 is less than 0, then there is a root that exists between 1.0 and 2.0. Okay. So now we know that there is a root that is existing between 1.0 and 2.0. So if we have that root as alpha, then f of alpha is going to be 0, because alpha is a root. It leaves no remainder. Okay, alpha is the root if it leaves no remainder. Recall from your remainder theorem of paper 1. Okay, so now we are going to extract this information and we put it in the table. So here I have my values of x, here I have fx, here I have 1.0, I have alpha, I have 2.0. For the case of 2.0, the value there is negative 0.09. 0.0907. For the case of alpha, we shall have the 0. Here we shall have 0.3415. So as usual, gradient AB is equal to gradient AC. A is here, B is here. So I will have 0 minus, this is 0.3415 divided by alpha minus 1.0 being equal to gradient AC. A is here, C is here. So I will have negative 0.0907 divided by this negative 0.07 divided by minus, first of all, 0.3415 divided by 2.0 minus 1.0. So there we are interested in finding the value of alpha. We are interested in finding the value of alpha. So 0 minus 0.3415, we get negative 0.3415 all over alpha minus 1 equal to, so this minus that, you will get negative 0.4322 divided by 1. Cross multiplying, you will end up with negative 0.4322 alpha minus, plus 0.4322 giving us negative 0.3415. So when we solve there for alpha, we shall end up with alpha being, and here we have been dealing with trigonometrical functions. Let's try out this. Show that the equation x plus 3 tan x equal to 0 has a real root between 2 and 3. Hence, use linear interpolation 1 to find the approximate of the root. This is number 1. Number 2. Show that the equation exponential x sine x equal to 1. So those are the questions that we have to try out. Like I said, we do math through practice. So this is what this channel is about. After I have shown you what to do, you go ahead and do it. I give you an opportunity to do it. You experience it by yourself. You do it yourself. And this is what this channel is doing. One example, you do it. Okay, so please don't forget to subscribe to my channel.